This video is the first in the series to demonstrate some of the abilities of R to produce graphics to show data. We need to think about data as one of two types. On the one hand, we can have categorical or discrete data. So if we were to go out and count the number of oak trees and the number of pine trees in the arboretum, then we would be counting discrete data. So every tree would be either a pine tree or an oak tree. So we could calculate the total number of both. So count data would be a case of categorical or discrete data. On the other hand, if we're measuring something like the heights of people, then we expect a spectrum of heights that there's no reason why any particular person has to conform to a particular height. So we would have a distribution of data that we could call continuous. Now, the graphical representation of these types of data vary. So we're going to first talk about categorical data or the discrete data, how one might represent that sort of information graphically. Most people, when they think about categorical data, are used to looking at pie charts. And here is a pie chart of the breakdown of the political parties of the European Parliament. And you can see that there are 8 parties in the European Parliament, and some are more popular than others. So taking a look at this pie chart, we can see that the most popular one is the EPP, still less than 50% of all individuals, and the next is the S&D, and then this one looks like it's third, but then the others, they're sort of hard to tell apart. How do they rank relative to each other? It turns out that R can produce very high quality pie charts, but we're not going to learn how to do that. And the reason for that is because pie charts are horrible. And one of the reasons is it becomes very difficult to distinguish numbers of intermediate categories in your pie. So here we're looking at these two here, which one is bigger? And this one, which one is bigger? So it's very difficult to tell. Sometimes you see people explode their pie charts, and these are the different slices of pies. And even here, it's not intuitively obvious all the time which one is bigger. Is this bigger than this? Maybe marginally smaller, but it's very hard to tell. So a good way to really tell the difference between the different sizes is to use a bar chart. And here it's perfectly obvious which is the most popular, the next most popular, and we can rank them all the way down to the least popular one down here in this catch-all term here. So a bar chart is much more valuable in terms of taking a look at categorical data than a pie chart. And a couple of other reasons that pie charts are bad. One is that particularly if you have a three-dimensional pie chart, it can be misleading or perhaps even intentionally lying to you. And here is a case where we've got a 3D pie chart, and you remember if we go back we can go back to here, that this was the red, which is about 190 or so, and then this was the blue, about 270. So pretty dramatic difference between the two, almost a quarter or so more in the EPP than in the S&D. But when you have this three-dimensional representation, and by putting this portion of the pie forward, it makes it appear larger than it actually is. So looking at this quickly, you would not guess that the blue was in fact significantly larger than the red. So that can be misleading. And anytime you see an exploded three-dimensional pie chart, you've got to figure someone's trying to pull the wool over your eyes. And here's an example of that. Here we have a pie chart that shows the different sources of stratospheric chlorine. And what you can see is that this exploded pie chart here has HCl and CH3Cl here, but this HCl represents 3% of the total. So does this. And this looks so much bigger. And 15% is caused by CH3Cl. The CCl4 is 12% here, but this also looks quite a bit larger than the mere 3% difference that you would see in actuality. So pie charts are something to be avoided. Pie charts can be useful if you're trying to show a percentage of a whole. So as an example, here we have the amount of property taxes in Detroit that were due and were paid in 1 year. And what you can see is that about 69% of people paid their taxes, and about 32%, 31% failed to. So they were delinquent. So that's not a bad use of a pie chart, but it's not really necessary. You could just say that 31.7% of taxes in Detroit were not paid in 2011. But I want to end this discussion of pie charts with my favorite pie chart of all time, which I think is an effective use of a pie chart, and that's right there. So how do we go about best representing categorical data? Well, what we want to do is to use bar graphs. And so let's go into R, and we'll get out of PowerPoint here and go into R. And what we're going to do is to go up into our script here, and I'm going to use one of the built-in data sets in R. And this is a motor trend study on cars. And so what I can do is just load that up, and here it comes. So it's always good to enter a structure command, and people that work with R a lot just call this the stir command. So you stir your data. So we're going to stir empty cars to see what we get. And what we see are a number of, well, we see that there are 32 different kinds of cars in this particular study. And for each of them, they measured the miles per gallon and the number of cylinders and the number of gears and so forth. Anytime you're in R and you want more information, you can always ask. And so what we can do is to ask for a little more information on this particular data set. And now we have a whole lot of information. So we know the data were taken in 1974 for Motor Trend, 32 observations. And so we could find a little bit more explanatory information there on this particular data set. Well, if we're going to make a bar graph in R, what we have to do is to first total up the number of individuals in the particular categories that we happen to be interested in. So what I'm going to do is to say, I would like to know what the distribution of cars is with numbers, different numbers of gears. And so I know that some cars had 4 forward gears, some had 3, and some had 5. So what I'm going to have to do is to ask R to sum up all the different cars in the study as a function of how many gears they have. So I'm going to set up an object. I'm just going to call it gears. And then what I'm going to do is just to tell R, make a table. And I want you to use this data set. And I want you to use gear. So you can see gear is down here. So we're going to run this. And it seemed to run because I don't end up with an error down there, but I want to print it. So I just type it and print that, and I had an error. So what did I do wrong here? Oh, I put the wrong thing in. So gears, I called it gears. And so here we have, there are 15 of the cars had 3 gears, 12 of the cars had 4, and 5 of them had 5. Well, now it's pretty simple to get R to make us a quick little bar plots, as they call it. So what I'm going to do is just to say, make a bar plot, and I'm putting in my table, which is bar plot gears, and there it is. I now have myself a little bar plot that shows the data very nicely. And what I can also do is to add additional information here. So I'm telling it where to plot it, but I can also give it a title. So we'll just call this car, oops, quotation mark there, car gear distribution. And need the equal sign here. And I could also label the X labels and Y labels. So I'm going to say X lab equals, oops, number of gears, and we got that, and the Y label equals, I'll call that frequency, and I'll run that, And so I've got a not a bad looking little graph there. It's obviously not really something I want to publish, but it shows the information that I wanted very nicely. And by the way, when you're working down here in the plot window, if you want to get a good view of a graph that you're making, you can always zoom and it will make it come free like so. And if we were ready to save this particular plot, we have three ways of doing it. One is that we could copy it to the clipboard and we could paste it into Word or some other document. We could save it as a PDF, or we could save it as an image like a JPEG or a TIFF or a bitmap, whatever you want. So those are useful ways of getting your graph to a publication that you're going to write up.